Good morning, everyone. Just putting together the final touches on my um, project here for DEF CON, and today we're going to be bypassing ASLR, so address space layout randomization, and I'll show you what it does and how we get around it in 32-bit here shortly. Here's my binary. As you can see, it has stir copy, which doesn't do bounds checking, and it has a small buffer of 8, so a tiny, tiny buffer. So what we're going to do, we're going to overflow this buffer, of course, because of the vulnerability here. And then we're going to bypass DEP, data execution prevention, by doing some return-oriented programming. And we're also going to bypass ASLR. So let's jump into it. The first thing you have to do is, let me just copy this and paste it right here to the top. Okay, first things first, you'd want to compile your ASLR into a binary. So let's go ahead and do that. Okay, so now we can just come over here. I have this whole program put out, just copy and paste. That way, the last time I taught this in Ukraine, occasionally people would put in just like a tick in the wrong place and it would slow class down and lead to frustrations among students. So this time I made it all withdrawal IO, and yeah, it seems to be going really, really good. So fingers crossed for DEF CON. So let's get back. So we can compile this. So we're going to compile it with no stack protector, no pi, ASLR.c, the source file we looked at, and we're just going to output it into ASLR, which will be this executable here. And as you can see, everything is perfect. Okay. So first things first, let's check to see if our randomization is turned on. So as you can see, it's 2, so it is turned on. So that's all we need to do there. So just come over here to LDD, and I'll just show you, now that we have randomization on, as you see, these base addresses are for ping are changing every single time we load it. Okay, so that's the hard part of getting around ASLR. However, due to the size of entropy a 32-bit system has, we can actually brute force this and get around it. So, yep, that's what we're going to do today. I'm just here drinking my coffee and relaxing this afternoon, so I figured might as well put out a video. Okay, so the first things first, we open up GDB where we live, and we open up the executable file here. So the first things first, we have to set disable randomization to off for this to work, and that's just here in the debugger, and that's good. So the first things first, we're going to disable the main function. So we'll come over here and we'll copy and paste in disassemble the main function. As you can see, nice that I have it called a vulnerable function here. So let's disassemble the vulnerable function right here. And now we need to put a breakpoint at stir copy. So as you can see, here's the stir copy here. So we copy this address right here, and we put a B star, and we put our breakpoint in here. So the first things first, I want to run it. I'm going to run it with some Python here. Instead of just putting in AAAA, we'll do it with some Python to make it look better. So we're going to run it with our input of 20 A's. So let's hit that. Okay, so the first thing we do, let's examine the stack before the stir copy. And as you can see, nothing's been put onto the stack yet from our input. So we hit next instruction, which we'll call the stir copy, and examine the stack again. And we can see our 41s here, plain as day. So let's find our base pointer and print DEP, and it's at C18. So here's C0, 1, 2, 3, 4, 5, 6, 7, 8. So we have all of our stack is currently overwritten, so that's really good for us. If we take copy XWX of this one right here, here's our main function right here. So what we're going to do, we're just going to hit continue. We have everything covered off. So what we're going to do now is the same way we bypassed DEP. We have to first set up on the return function, which we just looked at. We have to put system on the return function. Argument 1 place, we have to put exit for the program to exit. And then on argument 2 vector, we need to put in bin sh, which will give us our DEP bypass, because we're not executing anything on the stack. We're using return-oriented programming to put this in. So what we'll do, we'll put in our 20 A's again. We'll put in 4 B's, 4 C's, and 4 D's to be placeholders for our system, our exit, and our bin sh function. Okay, so we examine 30x, and there's nothing put on the stack yet, so let's hit next instruction. Bring up our 30 display again, and as you can see, the buffer is full of A's. B is in the place of a return function, and this is going to be where system needs to be called. This is where the exit function will go for the system, and here's the bin sh, which will be the argument. Okay, so that's what we have going there. Everything is lining up perfectly. Excellent. So right now I can hit C and continue on. So next things we have to do is I have to start grabbing info from here in PETA, and I need to find where our system function stays, where our exit function is, and where our find bin sh is. And here we go. So now we have our 3 addresses right here. So now I'm going to open ASLR.py with my mouse pad. And thankfully, I already had this all set up for the students. So all you had to do is sort of plug and play with this one. So we'll put the system address right here. So we flood it with 20 A's. System B7, D9, 52. Okay, so it's the same system address as earlier. And then we need to put in our exit function, and our exit function is B7 D4. So this one is a bit different. So let me just chop this one out. And you can see the entropy is really, really small on these. Okay, so there's our exit, and now we need to find our bin sh. And as you can see, it's just barely changed from the past one that I had put in here just for a placeholder so my students know how to do it. So here we go. So now we have our system, and I'm going to copy this system here and put that one in as well. They're all different. My mistake. So let's put this in, and that is that. So now we have our Python script written. So file, save. Now this is going to write it out to ASLR.text once we run it. And then we'll use that in a while true loop to brute force the system. Basically, what will happen, we should be able to get it in about 128 tries, but it's going to keep trying system until it hits the right system, and then everything else lines up and we fucking take over. So here we go. So let's we can exit out of here. Now let's do Python 3 ASLR.high. Now, if we have a look, ASLR.text got made right here, thanks to that file. So what we're going to do, we're going to run it in a while true loop and see if we can brute force this. This is the fun stuff. So here we are, we're still in our binaries folder. So while true, we're going to run ASLR, the program, and we're going to cat ASLR.text into it as an input. And when it's done, it's done. So let's hit enter. As you can see, there's segmentation faults, there's illegal errors, there's everything, segmentation fault, buffer content. And as you can see, who am I? Lee. We got shell. We bypassed ASLR. We bypassed DEP. So I hope that's fun. I'm just putting together the main part of my DEF CON program is now done, my workshop. So now I'm just going in and fluffing it up and putting in some real world context for my students to follow along. I hope you enjoy this, and there'll be lots more to come. Take care.